To my right, I have a circle. And now, if I draw a line that passes through the circle at 2 points, and if the line is inside the circle, this line is called a chord. So now, I'm going to draw two chords that intersect. So these two lines are called chords. And so now let's draw some points. A, B, C, D, and E. So intersecting chords theorem states that A, E times E, C is equal to B, E times E, D. So let's try this with an example. So let's let AE be equal to 6, EC be equal to 4, and BE be equal to 3. Now what is the value of ED? Well, we have that 6 times 4 is equal to 3 times ED, or 24 is equal to 3 times ED, or 8 is equal to ED. And so ED is equal to 8. Okay, so now I'm going to prove the intersecting chords theorem. So let me draw a circle first. That isn't perfect, but that will do. So let's draw two chords. Let's say here and here. Let's call these points A, B, C, and D. So now the key to our proof of the intersecting chords theorem is to connect lines AD and BC. And now let's call the intersection of AC and BD, or the intersection of the two chords, to be E. Now we know that angle AED is equal to BEC. And now let's look at the arc AB. So let's look at this arc over here, starting at point A and ending at point B. Now we notice that angle ADE is part of this arc. ADE is equal to AB. Also, notice that ACB, the angle ACB, is also equal to the angle AB. And so this implies that ADE is also equal to ACB. And now we have proven by angle-angle similarity that these two triangles are similar. So now that we know that ADE and BCE are similar triangles, we can then set up an equation. And so AE over DE is equal to BE over CE. And so now, multiplying both sides by CE and DE, we get that AE times CE is equal to BE times DE. And so we have proven the intersecting chords theorem, and now we are done. Alright, now let's get into some problems. So our first problem is above the board. So I've already drawn a pretty good diagram of the problem right here. So we have a circle centered around O, AO being equal to 5 root 2, and AB being the diameter. Now CD is a line that creates a 45-degree angle with AB, and the intersection of CD is E. Now the line BE is 2 root 5. So first, I want to point something out. The question is asking for CE squared plus DE squared. Now, CE squared plus DE squared is equal to CE plus DE all squared minus 2 times CE times DE. This can be shown by expanding CE plus DE squared. So first, let's actually solve for CE times DE. So by intersecting chords theorem, we know that BE, or 2 root 5, times AE, or 10 root 2 minus 2 root 5, is equal to CE times DE. AE is equal to 10 root 2 minus 2 root 5 because the radius is equal to 5 root 2. And so AB is equal to 10 root 2, so we subtract BE from AB to get AE. Alright, so now multiplying these radicals, we get 20 root 10 minus 20 is equal to CE times DE. But we're looking for 2 times CE times DE, so 40 root 10 minus 40 is equal to 2 times CE times DE. So now let's substitute this back into our expression. So now substituting this back into our expression, we get that CE squared plus DE squared is equal to CE plus DE all squared minus 40 root 10 minus 40. Now we can remove the bracket and distribute the negative sign to get minus 40 root 10 plus 40. Okay, now let's solve for CE plus DE. So now is when this question becomes a little bit complicated. So first, let's consider triangle COD. As you can probably tell, I'm not the best at drawing straight lines. But since CO and DO are both radii, we know that this is equal to 5 roots, and DO is equal to 5 root 2. Now, let's draw the altitude of this triangle from O, and let's call this point X. So now, since this is an altitude, we know that this is 90 degrees. And since this is 45 degrees, we know that angle EOX is equal to 90 degrees minus 45 degrees, which is also equal to 45 degrees. And so triangle EXO is an isosceles triangle, Therefore, OX is equal to EX. Well, now let's focus a little bit more on triangle EXO. So, drawing triangle EXO, we realize that OE is equal to root 2 times OX, which is also equal to root 2 times EX. But we also know that OE is equal to 5 root 2 minus 2 root 5, since OE plus EB is equal to OB, and OB is a radius. And so 5 root 2 minus 2 root 5 is equal to root 2 times OX. And so now dividing both sides by root 2, we get 5 root 2 minus 2 root 5, all over root 2 is equal to OX. Now we simplify this radical. Now 5 root 2 over root 2 is equal to 5. And 2 root 5 over root 2 is equal to 2 over 2 root 2 times root 5, which is equal to root 2 times root 5, which is equal to root 10. And this is equal to OX. Now, since OXE is a 90-degree angle, we also know that OXC is a 90-degree angle. So OXC is a 90-degree angle. So now, we can apply the Pythagorean theorem to triangle OXC. And so CX is equal to the square root of CO squared minus OX squared. Now CO is equal to 5 root 2, so CX is equal to the square root of 5 root 2 all squared minus 5 minus root 10 all squared. Now 5 root 2 squared is equal to 25 times 2, which is equal to 50. So CX is equal to the square root of 50 minus 25 minus 2 times 5 times the root 10 plus 10. And so this simplifies to 50 minus 25 plus 10 root 10 minus 10. And so CX is equal to the square root of 15 plus 10 root 10. But now I want you to notice something. CO is equal to DO. And so triangle COD is an isosceles triangle. And so it is also true that CX is equal to DX. And now CX times 2 is equal to CD. But remember that CD is equal to CE plus DE. And now we know how to solve the problem, because now we know that 2 times CX is equal to CE plus DE. So we get 2CX is equal to 2 times the square root of 15 plus 10 root 10. Distributing the 2, we get that 2CX is equal to the square root of 60 plus 40 root 10. And since 2CX is equal to CE plus DE, we can then substitute the square root of 60 plus 40 root 10 up here. And so the square root of 60 plus 40 root 10 all squared minus 40 root 10 plus 40. This is equal to 60 plus 40 root 10 minus 40 root 10 plus 40. And so the answer we are left with is 100, since these two 40 root 10s cancel out. And so we are done. Alright, thanks for watching. Hopefully you enjoyed, and hopefully I'll see you next time.